So the first point we have seen was what is meant by the computer network. So it is a group of computers which are linked to each other, and due to this togetherness of these computers, it is allowed to share the resources, data, or the applications with each other. These are some of the types of the network: LAN, MAN, WAN, and PAN that we have seen in first lecture itself. So all these networks are used for a specified purpose only. Then the after that we have seen what are the uses of a computer network, means why it is used or why computer network is necessary. So we are experiencing in our day-to-day life lots of uses of computer network. Apart from that, I have listed some of the uses over here. For example, the services provided by the network for companies and the organization. Okay, so network, the whatever services provided by the network to the companies. So first is the resource sharing. For example, there are one printer is shared in one department. Then due to the network or the network, we will have 100% data availability all time. Data loss is not there. Also sharing of the resources saves our money. It provides a high communication medium. Then the second use we have seen was the service provided by the network for a particular person or the individual. For example, we are doing online shopping, e-banking, then we are doing or we are sending the emails, chat box, then we are conducting the online lectures, video conferencing, all. Then the next is the interactive entertainment, as like your online games or quizzes and all. So these are some of the uses of the computer network, and these are few. As like this there are lots of uses of the computer network. Now let's see the second point in this chapter. The name of the point is the network software, or we can say that the network architecture, how actually network is designed and how the data is actually sent, or how the communication is happening between the two nodes or two parties that we have to see. This is the general diagram of a network software, or we can say the architecture, where the layers, or it is a set of layers along with the protocols and interfaces, and these are arranged in a stack like structure. Stack in the sense one layer above second layer, then second layer above third layer, likewise. So it is a stack like structure which is having some set of layers, and these layers follows some protocols and interfaces. Okay, let's see that host 1 is sender and host 2 isn't receiver, and between these two the communication is happening or the data is being sent. So you can see that there is a physical medium available. Okay, so actual communication or data is being sent by the sender to the receiver is happening from the physical medium only. So physical medium is actually responsible to send and receive the data. So what is this physical medium? So we can say that any application through which we are sending the data and any application through which we are receiving the data. So that is not your physical medium. We can say that physical medium is close to the user. Okay, close to the user means it is the first layer or first medium through which or which is directly interacting with the user. Okay, suppose I want to send any data, so I'll use that physical medium and I'll send that data. After sending that data will travel through the network and it will receive to the receiver. Receiver will again receive the data by using same physical medium or any application. That's why we are saying that this physical medium is close to the user. Right. Now, what is mean by these protocols? Protocol is nothing but it is an agreement between the two communication parties on how the communication should be processed. Okay, what is mean by the protocol? It is an agreement between the two communicating parties on how communication should be carried out. That is nothing but the protocol. Okay, so what agreement means what? How data should be sent, what should be the size of the data, then whether it should be wrapped with headers or not, what what strategy should be followed, how encoding should be done, how decoding should be done, what should name should be given to the data. So all the rules which are required to carry the data from sender to the receiver, that are decided by this protocol or with the help of this protocol. So every layer is having its own protocol. So layer 5 protocol, 4 protocol, 3, 2, and sorry, here it is 1, layer 1 protocol. Okay, so they decide layer 1 and layer 1. This layer 1 is from sender and this layer 1 is from the receiver. They both decide how to communicate with each other. That is being decided by these two layers, right? So that is the meaning of the protocol. So I have shown the arrows over here, that layer 1 to layer 1, 2 to this one, 3. So it means that the communication is happening layer to layer. Okay, but actually this is just a consideration that layer 1 is directly communicating to the layer 1, layer 2 is communicating to 3, and likewise. But actually when the data is being sent, the communication or data is happening from layer 1 to layer 2, 3, 4, 5 of sender, and from here in a reverse manner it reaches to the receiver, right? So from this layer, layer 1 of host 1, it will go to the layer 2 of host 1, then layer 3, then 4, then 5. From fifth layer, it will go to the layer 5 of host 2, then 4, then 3, then 2, and then 1. And then it will reaches to the receiver. So this is the path of the communication. Okay. So from here to here, likewise, it will go to this. From here, it will again go to this, and from the receiver side, it will reaches to the destination. So this will be the path of sending the data. Okay. Now, one more thing is available over here, which is nothing but the interface. This one. Layer 1 2 interface, layer 2 3 interface, 3 4 interface, and 4 5 interface. So what is interface? It is nothing but it is used to define which primitive operations and services the lower layer makes available for the upper layer. Okay, why the interface is used? It decides which operations and services layer 1 is going to provide to the layer 2, then layer 2 is going to provide to the layer 3. 3 is going to provide to the layer 4, and 4 is going to provide to the layer 5. So that is decided by the interface. So that's why the name is given as 4-5 interface. So layer 4 is going to decide which operations and services it is going to send to the layer 5. Okay, so that is the general way of communication in a network software or network architecture. So why this actually it is done like this, means layer wise, or why the layers are arranged in a stack like structure? The reason behind this, within a network lots of things are happening. Okay, and to make the architecture very simple and systematic, the layer it is arranged in a layer wise structure. Clear. So this is nothing but the network architecture or network software in through which the communication is happening between the sender and receiver, or between two parties, any two parties. Okay, let's see one example how the data is being actually sent. So this is one example I have taken. For example, M1 is a message which I want to send from this sender to the receiver. Okay, now how it will go? So in last lecture I also told you that addressing is required. Okay, addressing in the sense headers are added to your message or to your data. What is the reason of adding the header is that the receiver should know from which sender the message has come. Okay, so that is the reason that headers are added. So whenever a message travels through all the layers, it adds its own header or its own address to that message. For example, now M1, for example, this is my layer 1. Okay, so at the layer 1, when the message comes, it adds its own header as a H1. When it passes to the next layer, for example, layer 2. So at this layer M1, along with the header 1 message, it also add its own header, that own address as a H2. For example, again it will go to the last layer, for example, layer 3. So at this third layer, it will add message, then header 1, header 2 and header 3. Okay, so it is nothing but every layer or every layer through which the message is being passed, that layer adds its own header to the message, and this whole thing is happening at which side? It is your sender side. That's right. Then next, so as I told you in earlier diagram, this is the physical medium through which your data will be sent to the receiver. So at the receiver side again, the reverse process will carried out. So now receiver is having header 3, that is layer 3 address, layer 2 address, layer 1 address. So when it passes to the next layer, for example, layer 2, this is our layer 2. When it reaches to the layer 2, it removes layer 3 and layer 2 address. Reason is that from layer 2, this message has to go to layer 1 only. So it doesn't require this H2 and H3 now. It only requires H1 now, right? From here it has to go to the H2, so that's why H2 will be there with the message. But from layer 2 it has to go to the layer 1 only, reverse manner. So that's why it will remove this address H3 and H2, and for layer 2 H1 will have a only header. And when it reaches to the layer 1, again H1 will be, or header will be removed, and original message will be received by the receiver. Am I clear? Yes. Am I clear? Or should I repeat again? Should I repeat? Or it is clear? Network software or network architecture? Am I audible? Speak out something. Yeah,
Yes,
Shubham.
ma'am. Yes, you are
Okay.
audible.
Audible ना? समजलं?
रिपीट करा
Is
मॅडम एकदा.
हाँ मैम समझ गए.
repeat. Okay. I'll repeat. So network software means what? So it is nothing but the arrangement of the layers. Okay. Now, why these layers are arranged, or why this network architecture is made as like a stack structure, layer 5, 4 means layer मध्ये का arrange केलेला आहे? So to reduce the complexity of your architecture and to make it very simple. Okay. That's why it is arranged in a layer like structure. That is the reason. So we are having two main things over here, protocol and interfaces. Protocols means what? In which manner the communication should be happen, that is decided by sender and receiver, or two communicating parties. या दोघांच्या मध्ये कम्युनिकेशन कसं झालं पाहिजे, म्हणजे डेटाची साईज काय असेल, तो डेटा मला कोणत्या फॉर्मॅटमध्ये येईल, त्याला हेडर्स ऍड होणार आहेत का नाहीत, हे सगळे जे रूल्स आहेत, दॅट इज डिसाइडेड बाय दिस प्रोटोकॉल्स बिटवीन two communicating parties, means host 1 and host 2. That is nothing but the protocol. Interfaces means what? So layer 1 sends the data to layer 2 sends 3, 3 to 4, 4 to 5, and here in a reverse manner it is happening. So when this layer 1 is communicating to the layer 2, which operations and services will be provided by layer 1 to the 2. It is decided by the interfaces. That is nothing but the interface. ओके. लेयर 1 आणि 2 ह्या दोघांच्या मध्ये लेयर 1 लेयर 2 ला कोणते ऑपरेशन्स किंवा कोणत्या सर्व्हिसेस प्रोव्हाइड करणार आहे हे कोण डिसाइड करतं तर इंटरफेसेस डिसाइड होतात. ठीक आहे. So these are the two terms which are used in a architecture. Now actually what is said that the communication is happening between these two layers, layer 2 to layer 2, layer 3 to 3, 4 to 4 असं कम्युनिकेशन होते असं arrow मी इथे दाखवलेलं आहे. It is shown. But actually when the data is being sent, the communication is happening like this, as I told you. So from physical medium, the data will be sent to layer 1, from 1 to 2, 2 to 3, 3 to 4, and 4 to 5. So it is the sender side. From sender, when it goes to the receiver side, from fifth layer to the fourth, 3, 2, 1, and then it will reach to the user. So that is the way of communicating. Okay. ह्या मॅनरला तुमचा डेटा सेंड होत राहील. Let's see one example. Okay. So suppose this is my sender side and this is receiver side. M1 is message which I want to send from this side to here. Okay. So it is having three layers. So as I told you, every layer add its own header. Header is nothing but the address of that layer, so that receiver will understood that this message has come from this layer and this layer. That's why ज्या ज्या वेळी मेसेज तुमचा लेअरला जातो त्या त्या वेळेस काय होतो तो लेअर स्वतःचा ऍड्रेस त्याच्यामध्ये ऍड करतो. That is nothing but the headers. Okay. So M1 is a message, H1 is added, M1 is message at the layer 2, H2 is added along with the H1 at layer 3, M1, H1, H2 and H3. When it goes to the receiver side, so receiver side ला गेल्यानंतर this is my L3 level. Okay. So when it reaches to the L3, at that time these headers are not required. Okay. So it just removes it and send to the next layer. When it reaches to the L2, it removes the other header as a H2 and keep only H1. And when it reaches to the layer 1, it remove all the headers and only original message is received by the receiver. Correct? So this is the whole process how the data is being sent within the network. I hope it is clear now.
Yes, ma'am.
Huh? Any doubt? Anybody is having any doubt?
No, ma'am.
No. No, no? Okay. So let's go to the next point. Hmm? So while this network software is designed, there are some issues which we need to which needs to be taken into consideration. ओके. ज्यावेळेस नेटवर्क सॉफ्टवेअर किंवा आर्किटेक्चर डिझाईन होत असतं त्यावेळेस इश्यूज अशा आहेत की ते लक्षात घेऊन ते नेटवर्क आर्किटेक्चर डिझाईन केलं जातं. व्हॉट आर दीज इश्यू आर दिस वन. फर्स्ट वन इज द ऍड्रेसिंग. So addressing means what? As I told you, for every layer, the headers or the address should be added so that receiver should understood from which sender the message has been sent. So that is nothing but the addressing. We have explained this. No need to repeat it again. The second issue is very important. Error control. Okay. So as I told you, there is no communicating medium which is totally error free. We can't predict that yeah I have sent the message and there is no error within the communication medium मध्ये error नाही किंवा network मध्ये error नाही असं होत नाही. 100% error free message or error free communication is not possible, but we have to control that error. If it is happening, we have to control that error. So error control mechanism should be added in every communication. Okay. So what is this error control? So there are some what we can say algorithms. For example, CRC is there, then Hamming code is there, and lots of strategies are there which we are going to see in next part. So that are used to control and detect the error. ओके. एरर झालेली आहे का नाही मेसेज मध्ये ते ओळखायचं, आणि जर झालेली असेल तर ती कशी हे करायची, कमी करायची. फॉर दॅट द स्ट्रॅटेजीज आर युज्ड. ऑल दॅट कम्स अंडर अ एरर कंट्रोल स्ट्रॅटेजीज. So this is the second issue which should be considered. Okay. Then next is the flow control. Flow control means what? Suppose this is my sender and this is my receiver. Okay. And communication is happening between these two. Sender is sending the message, receiver is receiving the message. But suppose sender is too fast and receiver is not having that much capacity to receive the message, or receiver is not able to match the speed of a sender. सेंडर ज्या स्पीडनं मेसेज सेंड करतोय त्या स्पीडला मॅचअप करायची रिसिव्हरची कपॅसिटी नाही, किंवा रिसिव्हरकडे तेवढा स्पेस पण नाही की जेवढ्या फास्ट हा सेंडर मेसेज सेंड करतोय ते सगळे मेसेज ह्याच्याकडे स्टोअर करून घ्यायचे. ओके. हे नाही. सो व्हॉट विल हॅपन इफ दिस इज द सिच्युएशन दॅट सेंडर अँड रिसिव्हर बोथ आर नॉट सिंक्रोनाइज्ड विथ इच अदर, they are not matching with each other. So what will happen? So there will be a loss of data, because suppose it is having the capacity that it will store only 101 एवढंच हा स्टोर करतोय, but sender has sent 10 then 1 then 1 and then 1 हा डेटा त्याने सेंड केलेला आहे. So only this data will be stored by the receiver. These two ones are getting lost. Okay. So data loss will be happen. So to reduce this all communicating, what we can say, communicating, uh, to reduce this data loss, there must be a flow control strategies. Flow control means what? There must be synchronization between sender and receiver. How to send the data? What should be the rate of sending and receiving the data? Whether receiver is capable to receive the data. Same is exactly reverse is applicable to the sender also. Okay. Suppose receiver is too fast and sender is too slow. So that at that time what will happen? Receiver will be in an ideal stage unless and until sender sends the data. रिसिव्हरचं रिसीव्ह करायची कपॅसिटी जास्त फास्ट आहे पण सेंडरची नाहीये, त्यावेळेस काय होईल तर रिसिव्हर आयडियल स्टेजला राहील. हे असं घडलं नाही पाहिजे. सो दॅट स्ट्रॅटेजीज आर कॉल्ड कम्स इन अ फ्लो कंट्रोल स्ट्रॅटेजी, and that should be there in a network architecture. So that is the third issue. Then next is the loss of sequencing. So loss of sequencing means what? We have seen this concept in a circuit switching and packet switching. I hope everyone is remembering circuit switching and packet switching. Packet switching मध्ये आपण sequencing means what हे बघितलं होतं. Can anybody tell what is mean by sequencing or why it is required? Yes. Can anybody tell? Packet switching. पॅकेट स्विचिंग मध्ये बघितलं होतं सिक्वेन्स नंबर्स गरजेचे असतात. कशासाठी? No one. Then what is the use of taking lectures if you are not remembering the last lecture points? Hmm. Speak out. Abhishek, Omraj, Vaishnavi, all. हाँ बोला पटपट पट. श्रद्धा माळी, अनुष्का चव्हाण, शुभम, विशाल, नेहा, बोला जरा. What is the sequencing? Why the sequence numbers are required? Vaibhavi Patil, Pooja Patil. Yeah, unmute your mic and please take talk. संकेत, विजय. हा. It means that we are just taking the lectures and we are just listening the lectures, or I don't know whether you are listening or just you are signing in. Huh? Okay, let's see. I'll show you the diagram. Hope from that you get understood, or you will tell me what is that packet switching and why the sequencing is required. Whether diagram is visible? Now, this is the packets, okay, and these are received by the receiver in this manner. Now, tell me why the sequencing is required. Hmm. Why the sequencing is required? Yeah, speak up. Pratiksha, Shivani. बोला बोला फास्ट. Hmm. Or is it the thing we are just listening and forgetting all things? फक्त ऐकायचं आणि सोडून द्यायचं असं चाललंय का? हा, प्रसाद जाधव. डोंट लेव द मीटिंग. संकेत. कोण आहे संकेत? हा, बोला. फक्त ऐकताय सोडून देता असं चाललंय का? हा, वैष्णवी. वैष्णवी राऊत. Unmute your mic.
Yes, ma'am.
हा, सो काय आठवतंय का नाही आठवत? हे जी डायग्राम मी दाखवली आता त्याच्यावरच काय आठवतंय का नाही आठवत?
हाँ मैम, एक फ्लो
बघितलं एवढं
चार्ट
तरी
होता.
आठवतंय? काय होतं हे, कशासाठी पॅकेट्स केलेले आहेत? हा पॉइंट आपण पॅकेट स्विचिंग मध्ये बघितलेला आहे. सो व्हॉट इज दिस? वाय सिक्वेन्सिंग इज रिक्वायर्ड ओव्हर हिअर? सिक्वेन्सिंग म्हणजे काय हे त्यावेळेस मी एक्सप्लेन केलं होतं. वैष्णवींना अनम्यूट करायला लावले म्हणजे फक्त त्यांनीच द्यायची नाही, बाकीचे पण बोलायचे. ते असं जर असेल ना हा, हा, रोल नंबर 1.
Yes, ma'am.
Tell me what is the use of the packet switching, or why this sequencing is required over here? Hmm?
Packet switching path is
काय reason आहे?
not defined.
Not path.
It,
Path is not defined.
uh,
Okay. Then
it's
why
virtual circuit.
sequencing is required here? Yeah, but why sorry, sequencing is required? Sequencing का लागतं इथं? हा? Don't know.
Don't.
हा बाकीचे अभिषेक, हा अभय, don't know. प्रसाद. इट इज व्हेरी सिम्पल. सी काय होतं याच्यामध्ये पॅकेट्स जे तुमचे जाणार पॅकेट्स का केलेले असतात पहिल्यांदा वाय पॅकेट्स आर डन हा काय एक एक मेसेज आहे का नाही एकच मेसेज नंबर ऑफ पार्ट्स मध्ये डिवाइड केलेला आहे ठीक आहे आणि तो वेगवेगळ्या पार्ट मध्ये आपण डिवाइड केलेले राईट नाव हे पॅकेट्स ज्यावेळेस नेटवर्क मध्ये फ्लो होत असतात त्यावेळेस त्यांचा पाथ फिक्स डिसाइड नसतो त्यामुळे काय होईल रिसिव्हर कडे मेसेज जाईल इथं रिसिव्हरला जे मेसेज मिळेल त्यावेळेस मे बी पॉसिबल दॅट सी विल कम बिफोर एच्या अगोदर सी पोचेल डीच्या सॉरी डी नंतर बी पोचेल म्हणजे काय होते तर त्यांचा सिक्वेन्स आहे तो पुढे मागं होऊ शकतो ए सगळ्यात शेवटी पोहोचेल काही होऊ शकेल कारण का तर प्रत्येक जण स्वतःचा पाथ स्वतः निवडतो मग मे बी पॉसिबल दॅट डी पहिल्यांदा पोहोचेल ए लास्टला पोहोचेल असं होऊ शकतं मग रिसिव्हरला कळलं पाहिजे ना की बाबा हा कोणता नेमका मेसेज आहे मग कुठल्या सिक्वेन्सचा आलेला आहे हे कळलं पाहिजे त्यासाठी प्रत्येक मेसेजला सिक्वेन्स नंबर दिलेला असतो आणि तो इथं रिअरेंज केला जातो रिसिव्हरला सो आपण हे पॅकेट स्विचिंग मध्ये सगळं बघितलेलं होतं एक्सप्लेन केलं होतं मी तुम्हाला दॅट रिअरेंजमेंट शुड बी डन आय शो यू store resources needed yeah pre-setup reservation resource packet composites playoff yeah see here reassembled at the destination all the small parts has to be reassembled and it is nothing but the sequencing and it is possible through sequence numbers only so प्रत्येक मेसेजला एक युनिक नंबर दिलेला असतो and to with the help of that unique number the receiver will rearrange that message and original message will be received by the receiver so that is the issue which should be taken into consideration and which is called as the loss of sequencing मीन्स जर मेसेज जर प्रॉपर सिक्वेन्स मध्ये नाही गेला तर काय करायचं सो दॅट स्ट्रॅटेजी शुड बी टेकन इन टू कन्सिडरेशन वाईल डिझायनिंग द नेटवर्क सो दॅट इज द फोर्थ इश्यू देन नेक्स्ट इज द लॉंग मेसेज acceptance some layers or some architecture doesn't accept the long message they are having the limit of acceptance of the message in that case what should be the size of small message that should be decided means what एखादा मेसेज आहे हा खूप सॉरी लेअर आहे किंवा नेटवर्क आहे तो लॉंग मेसेज एक्सेप्ट करत नाहीये तर त्या केसमध्ये हा मेसेज डिवाइड कसा झाला पाहिजे त्याचे स्मॉल पॅकेट्स किती साईजचे असले पाहिजे प्रत्येक पॅकेटचा पर्टिक्युलर साईज काय असला पाहिजे हे डिसाइड करणं दॅट इज द नेक्स्ट इश्यू विच इज कन्सिडर्ड अँड last one is the routing issue okay routing means what it is nothing but the finding suitable path to reach to the destination that is nothing but the routing let's take an example that suppose within a network there are 100 nodes are available ओके 100 नोड्स म्हणजे काय तर स्टेशन्स आहेत फॉर एक्झाम्पल आणि स्टेशन नंबर 1 कडून स्टेशन नंबर 100 ला मेसेज सेंड करायचा आहे ओके स्टेशन 1 ला स्टेशन नंबर 100 ला मेसेज सेंड करायचा आहे सो इट विल ट्रॅव्हल थ्रू ऑल दिस or within the network so while traveling through the network as we have seen in a packet switching there are lots of ways are available ठीक आहे खूप सारे वेज असतात सो आउट ऑफ दिस विच इज सुटेबल टू रीच टू द डेस्टिनेशन दॅट इज डिसाइडेड बाय युझिंग राउटिंग स्ट्रॅटेजी और इट इज कॉल्ड एज अन राउटिंग स्ट्रॅटेजी त्या प्रत्येक पाथ मधला जे नेटवर्क मध्ये अवेलेबल आहे त्या पाथ मधला कोणता पाथ फिजिबल आहे डेस्टिनेशन कडे पोहोचण्यासाठी तो डिसाइड करणं दॅट इज नथिंग बट द राउटिंग ओके सो हा पाथ जो आहे दॅट कॅन बी डिसाइडेड विथ द हेल्प ऑफ द डिस्टन्स म्हणजे जे मिनिमम डिस्टन्स आहे त्याच्या थ्रू डेस्टिनेशनला पोहोचायचं हे स्ट्रॅटेजी असू शकते किंवा मिनिमम टाइम मध्ये मी रीच झालं पाहिजे डेस्टिनेशनला हे पण स्ट्रॅटेजी असू शकते किंवा मिनिमम नोड मध्ये मी त्या डेस्टिनेशनला गेलो पाहिजे. नोड मीन्स फ्रॉम वन दिस वन ओनली 2 nodes आय शुड यूज. सो एनी स्ट्रॅटेजी जेणेकरून डेस्टिनेशनला पोहोचताना इफेक्टिव्हली पोहोचलं गेलं पाहिजे. दॅट इज नथिंग बट द routing strategy, and there are routing algorithms are available that we are going to see in the next chapter, chapter number 6. So these are some design issues which are considered or which are uh, taken into consideration while designing an architecture. ठीक है? Yes or no? First is the addressing, then error control, then flow control, loss of sequencing, loss of message acceptance, and routing. These are the 6 issues. See, the question is asked on this, okay? Network software design issues. Write a note on this. So everybody has understood it, and I don't want only yes answers. Okay, because every time you are saying yes, and whenever I ask the question, there is no answer from your side. Yeah, tell me. What is addressing? What is error control? What is flow control? समजलंय का?
Yes, ma'am.
Others. समजलंय? Is there any doubt? डाऊट आहे, रिपीट करायचं आहे का पुढे जायचं आहे? Come on, speak up fast.
मॅम फ्लो कंट्रोलिंग रिपीट करा की.
Flow control. Okay. Any other point? No. Okay, I'll repeat all points क्विकली. सगळेच रिपीट करते. बघा, ऍड्रेसिंग सगळे काय आहे तर डिझाईन इश्यूज आहेत. डिझाईन इश्यू म्हणजे काय, आपण जे आता हे डायग्राम बघितले, हे काय एक आर्किटेक्चर आहे. ठीक आहे, आपल्याला डेटा सेंड करायचा आहे, त्यावेळेस हे असे प्रोटोकॉल यूज करण्यात होते. ज्यावेळेस आर्किटेक्चर डिझाईन होतं त्यावेळेस हे सगळे डिझाईन इश्यूज क्लिअर किंवा केले जातात. These are the main design issues. So first one is the addressing. Addressing म्हणजे काय? So this one, H1, H2, H3. These are nothing but the addressing. So when the message is traveled within the network, it should know where to go and from where or from which point it has come. कुणाकडून आलेला आहे आणि कुठे जायचंय हे माहित असलं पाहिजे, जेणेकरून रिसिव्हरला ज्यावेळेस तो मेसेज मिळेल त्यावेळेस त्याला समजेल की हा मेसेज मला ह्या लेखून आलेला आहे किंवा ह्या सेंडर करून आलेला आहे. हे सगळं समजलं पाहिजे. अँड दॅट इज नथिंग बट द ऍड्रेसिंग. हे सगळं कन्सिडर असलं पाहिजे. ओके, सो दॅट इज द फर्स्ट इश्यू. Second one is the error control. So as I told you, there is no communicating medium that which is totally error free. कोणतंच communicating medium असं नसतं की जे error free आहे. Some errors are there within the communication and
Ma'am,
that should be considered. Yes.
your voice is breaking.
Yes. Okay. Sorry. So error control means what? Ki there is no communicating medium which is totally error free. असं कोणतंच कम्युनिकेशन मीडियम नाही की जे पूर्ण एरर फ्री आहे. थोड्या तरी एरर्स त्याच्यामध्ये असतात आणि त्या एरर्स काय आहेत किंवा त्या कशा कंट्रोल झाल्या पाहिजेत हे समजून घेणं, दॅट इज नथिंग बट द एरर कंट्रोल स्ट्रॅटेजीज. ठीक आहे, ज्यावेळेस रिसिव्हरला सपोज विथ एरर मेसेज गेला, सो व्हॉट विल हॅपन, रिसिव्हर विल नॉट गेट एक्झॅक्ट मेसेज ऍज अ विच इज सेंड बाय द सेंडर. आपण बघितलं होतं सिग्नल सगळे हे होतात, व्हॅरी होतात. जर त्याच्यामध्ये नॉईज ऍड असेल किंवा अटेन्युएशन झालेलं असेल, दॅट इज नथिंग बट द इफेक्ट ऑफ द एरर ओनली. जर त्याला फॉल्टी डेटा मिळाला रिसिव्हरला तर उपयोगाचा आहे का? नाही. सो इट शुड बी कंट्रोल्ड एरर within the, or error should be controlled within the communicating medium, and for that different algorithms, different strategies are used. Okay, when the message is sent from sender to the receiver, and it comes under a error control strategy. That is the second issue. Now third issue is the flow control. Flow control means what? There must be synchronization between sender and the receiver. सिंक्रोनायझेशन म्हणजे काय, तर दोघांचं एकमेकांच्या सोबत मॅचिंग झालं पाहिजे. सेंडर शुड नॉट बी टू फास्ट, रिसीवर शुड नॉट बी टू स्लो, or receiver should not be too fast, sender should not be too slow. There must be synchronization between sender and receiver. So जर हे दोघांच्यात सिंक्रोनायझेशन नसेल तर काय होईल, देअर मस्ट बी अ डेटा लॉस. डेटा लॉस होऊ शकतो. So to avoid this data loss, the data which is sent by the sender, it should be controlled, and that is nothing but the flow control. Flow means rate of sending the data. हा एक कंटिन्युअस फ्लो न तो डेटा सेंड झाला पाहिजे. जर नाही झाला, फॉर एक्झाम्पल आय हॅव एक्सप्लेन दॅट सेंडर इज टू फास्ट, सेंडरची स्पीड खूप आहे डेटा सेंड करायचं, त्यामुळे तो काय करतोय, एक झाला की एक झाला एक डेटा सेंड करत जाते. बट रिसिव्हर इज नॉट दॅट मच कॅपेबल. मग काय होणार आहे, ज्यावेळेस सेंडर सेंडर सेंड करेल, वन सेंड केला, रिसिव्हरने रिसिव्ह केला, सपोज रिसिव्हर वन रिसिव्ह करतोय तोपर्यंत रिसिव्हर कडे झिरो पण आलाय, बिकॉज सेंडर फास्टली, जसा हा फर्स्ट झिरो केला की लगेच तो पुढचा सेंड करतोय. ओके, आले आले आले. So that should not be happen. That should not. येते मी जातो. So that is nothing but the flow control. Okay, so there must be synchronization between sender and receiver, so that data loss should be avoided. So that is the third issue. Then next one is the loss of sequencing. As I explained, sequencing कशासाठी लागतो, प्रत्येक पॅकेट हा स्वतःचा पाथ डिसाइड करत असतो किंवा स्वतःच्या पाथने जात असतो. मग खूप एखादा पॅकेट आधी पोहोचेल, दुसरा नंतर पोहोचेल, पण ज्यावेळेस रिसिव्हरला मेसेज मिळणार आहे त्यावेळेस त्याला ज्या फ्लोनं किंवा ज्या सिक्वेन्सनं सेंडरनं सेंड केलेलं आहे त्या सिक्वेन्सनं मिळाला पाहिजे. सो दॅट strategy should be divided, and it is the loss of sequencing. जर सिक्वेन्स नाही मॅच झाला तर काय केलं पाहिजे. So that is the next issue. Then next is the long message acceptance. Some architecture doesn't accept too much long messages. Okay, in that case that message should be divided into small packets. So what should be the size, minimum size of that particular packet? So it should get decided. So that is the next strategy. And routing means when the message is traveling through the medium or through the network, at that time it should select a feasible path that it should reach within minimum time, within short distance, and likewise. So that all strategy comes under a routing issue. Okay, so these are some issues which are considered while designing a architecture. Any doubt now? Is there any doubt?
No.
No. Okay, so this is the point. Then next point is network topology. So I think we should stop here because we are having the next webinar. So I'll forward link of webinar in your group. So just log into that webinar. Okay. So tomorrow again we are having next lecture. In that we will cover the next part. So I have forwarded the link. So you can just leave from here and you can log into the next link. Okay, wait a minute. I'll present in 2 minutes. Just a second.